All right. Hi, everybody. Great to be here. So I'm going to be talking today about the tech behind a design system that scales. This is going to include the tech choices we made when building our design system, what a design system is, and I'm going to show you a bit of the journey that we went through building our own system. So just quickly to introduce myself, my name's Monica. I'm originally from the States, but currently living in Berlin. And I'm working at a company called Sumup, and I'm going to explain what we're doing in just a few slides. So where are we going today? First things first, we're going to start out with a use case, a story that might sound familiar to you if you were ever working in front-end, as I imagine a lot of you are. And it might signal to you that a design system could solve some of the challenges that you are having in your day-to-day work. I'm also going to talk about what a design system is, how this might be different from a component library, if that's something that you're working on today. And I'm also going to talk about the specific challenges that we had and how we picked a tech stack to build our design system in that would address those. And finally, at the end, I'm going to show you where we came from and what exactly we built. But before I go into all of those details, I want to give you some context because scalability means something different for a lot of different companies at different stages in their life cycles. And I'm working at a company that started with 80 people when I joined, and today is more than 1,000 people worldwide. So I've seen it go through quite a huge transformation. To give you an idea of our product, we create this card reader, which allows small businesses to accept payments easily and without a contract. We're also operating in Brazil. In fact, our biggest office is in Brazil with more than 500 people working there. And it wasn't long ago that we were live in only 15 markets, but last year we more than doubled our footprint to be live in more than 30 markets. And as you can imagine, this completely changes the way that you work on absolutely everything, especially when it comes to software. So with this as a foundation, let's look at a use case. As many good things, it begins with a story. So one day, my coworker sent me this message on Slack. He was working on an input field that would accept some amount of money, and this was going to go into a screen where you could issue a receipt to someone and make a refund. But unfortunately, I was a bit surprised that he was working on this. And he was like, yes, you know, there are all these edge cases. You have to deal with so many different locales. It actually becomes very complex. But the reason I was surprised was because I had already built this exact UI component 6 months prior. And as you can imagine, it doesn't feel good to do duplicate work and realize that all that effort that you put in is completely wasted. And lo and behold, when we opened up the app, you could see that we had 2 pieces of UI that were trying to do the same thing, but in fact they were not. So you can see the currency is in the wrong place. They're made by 2 different developers, 2 different designers. And the funny part about this is that through a single interaction of our merchants, you could interact with both of these UI inputs at the same time. So you take a payment and then you do a partial refund. You're going to have an inconsistent experience in just 30 seconds of using our application. Now that sounds bad enough, but what could make it worse? Me and the developer who created these 2 UI components were actually sitting right next to each other when we did this. And you might think, that's really ridiculous. Do you guys even do code review? Do you speak to each other? I mean, it seems completely absurd, right? But the fact of the matter is that at some point, an application becomes sufficiently complex and you have enough teams that are working in parallel on different things that no one developer can have in their mind absolutely everything that is happening in the application at once. And to make matters worse, we're getting bigger, right? So we have engineering teams in 3 different countries and different time zones. And this team is doubling in size roughly every 12 months. So our last doubling of the engineering team was in the last 8 months. So if we're already being inefficient with where we are now because we are duplicating work, what's the point of adding more people? I mean, you're just going to be doing the same work over and over again. So this presented a question to us. how are we going to be able to scale the team and the product offering while also increasing developer efficiency and providing a consistent user experience? The answer was that we needed a system. Specifically, we needed a design system. Now, what is a design system, you may ask? I really like this quote, which I found on the Envision blog, which says that a design system is a collection of reusable components guided by clear standards that can be assembled together to build any number of applications. It sounds pretty cool, right? So, what does this mean more concretely? When you start out with a design system, I think you can break it down into two main aspects. You have the ideas, the design ideas. You have the patterns that you expect people to commonly use in your system. You have the forms, the shapes, the colors, the branding, and you have the language that you want to use to interact with your end user. And then you need to actually build stuff, right? Ideas don't just work on their own. So you create these artifacts, these embodiments of those ideas. And this can take the shape of a component library, documentation, things you build with your tools, and a process by which you introduce change. And when you combine your ideas and the artifacts that you've built together, you can create a design system, which is meant to evolve together over time. And this is what makes it fundamentally different than just something like a style guide, because it's meant to handle change and be adaptable. So there are a few ways that design systems, by their nature, are intended to help you scale. The first and perhaps most obvious one is that when you introduce a component library, you stop solving solved problems. So in our case, someone had already put in a currency input and we wouldn't have needed to do that yet again. And then I think a really big one is documentation. And what this gives you is it helps people to answer their own questions. When you have a team that is growing and you're onboarding new people all the time, and especially when you are in a distributed environment with different time zones, helping people answer their own questions is really empowering for them, and it makes them productive even when you're not online. As well, the tools that we use make it easy that our ideas and the things that we create are able to evolve. And it also creates a single source of truth. So you're not looking through your hard drive for whatever is the latest file. You know, this is on master. I know exactly that this is the state of affairs today. And finally, when you have a process, which is a critical part of a design system, you can allow people to make contributions to it while also keeping quality high. Now, I'm going to talk specifically about the scaling challenges that we had and how we fixed them with a design system and the technology that we use to do that. So the first thing is always about people, right? So as I already mentioned, we have a growing team and we're distributed in 3 different countries. We're also offering more and more products. We're expanding into all kinds of area in the fintech space. But at the same time, we're not a new company. We've been around for almost 6 years. And that means that we also have a tech stack that includes shiny modern things and things that were shiny and modern 6 years ago. So we have to handle both of those. And finally, we have a lot of teams that are working in parallel, and any kind of excessive process or too much manual labor is going to make it hard for them to want to contribute to a high-quality design system. So we need to think about how we can make that as efficient as possible. And now I'm going to talk about what specific solutions we had for each of these, and I'll go into them in depth afterwards. So for people, we gave them the most productive environment that we could, which was a component library workbench so they could develop components outside the context of an application. And we also gave them in-context documentation so they could do as much of their work as possible without having to context switch. When it came to products, we knew we wanted to keep our branding consistent, but we also knew we had different use cases where we needed to be flexible. For that, we introduced the concept of theming. But as I said, we have a pretty diverse tech stack, so we had to make sure that we had a way to get the CSS out later on, and I'll talk about how we did that. Finally, we try to automate as much as we can so that it's user-friendly to introduce high-quality changes, and we do that by automating bits of our documentation and regression testing. Now, before I dive into each of these individually, I want to lay the foundation for the tech stack that we chose. And this is to answer the question of why React. It's pretty controversial, to be honest. When you're picking a design system technology, a lot of people really believe that you just need to do it in CSS, because CSS is the primitive. It's something you know that every single web application is going to support. But I'm going to argue that that's not the right choice. So let's see what I have to say about that. Well, not so long ago, I was talking to a developer who had been working with jQuery for more than 10 years. And I was trying to explain to him why React is so great and he needs to pick it up. It's relevant now. I was like, yeah, you can put your JavaScript, you can put your HTML in one file. It's amazing, right? It makes you so productive. But he just didn't get it. I mean, he looked at me and he was like, Monica, HTML and JavaScript is like ice cream and pizza. They're good on their own. Why are you asking me to mix them together? I mean, it feels wrong, it tastes weird. And to be honest, he's not completely off, right? For a long time, this is exactly how we thought about our separation of concerns on the web. We love to have our perfect HTML templates that were ideally very pure, not much logic in there. We had our JavaScript, which made little modifications here and there. And we had our CSS, which was responsible only for design, never any logic, right? But the reality looked quite a bit different. All of these things got really out of control. So we had HTML templates that were really massive, doing a lot of things, responsible for a lot of logic. JavaScript that made strange changes to the DOM, and it were really hard to debug. And we also had CSS, where if you just nested something incorrectly or it wasn't specific enough, it was very unpredictable. And the really core problem that we had was that we tried to tie together all of these things using global names, such as CSS class names or IDs. And these are really brittle. It's super easy to accidentally screw one of these up and suddenly your page is not working and you don't know why. So what React brought to the table was being able to encapsulate the structure, behavior, and design of a UI element in one place. And that means when you're building a design system, you can enforce certain usages and patterns for the people who are consuming your system, which is really not the case in a pure CSS library. I can say that we tried a pure CSS library and failed miserably. And a lot of that is because at the time of creating it, people just use things differently. Yet there's too much open to interpretation. So this is why we picked React. Nowadays, I think there are a lot of other tools that could fill in for that, but the rest of the talk is going to be about things that are easily built on top of React. So with that in mind, let's look at how we thought about people when building our scalable design system. So we are using a tool called Storybook. I think this is becoming pretty popular nowadays, but in case you're not using it, let me just tell you what it is. Storybook functions as an isolated development environment. So basically, you get to build your UI without working inside of any one app. It also has a great plugin system, so you can extend it however you want to. Here you can see that the source code is embedded. You have all the props and prop types that are also available in there, and you get this almost for free. Now, it might seem that this is kind of trivial, but I'm going to tell you that this completely changed the way that I personally work, and I think the way that the team works. So the first thing it really gives us is efficiency. Sometimes you're working in an older app that doesn't have the best tooling, and when you're working in an environment like Storybook, it's completely optimized for developer experience. You don't need to get to the same context in the app to check your UI. It's just going to work and allow you to iterate really quickly. And the second thing is, which I think is probably the most critical, it keeps our UI components free of application logic. Now, when you want to make something reusable, it's not exactly easy when you're developing UI in the context of an app where you have all kinds of things there to help you. And what can often happen is that you build a piece of UI, you put it in your app, someone says, oh, I would love to reuse that. And then you actually need to detangle it from the context that you built it in. So what you get when you're developing in Storybook instead is you don't even have the chance to entangle yourself into the application, which makes the UI extremely reusable. And finally, it's super easy to find out what components are available. When a developer stumbles upon a component and they see that it has tests, it's working in the wild, and it's documented, they have very little reason to introduce an inconsistent version of that component on their own. So let's talk now about how we made our design system flexible enough to work with a lot of different products. So we did this by enabling theming. Theming is essentially something we're pretty much all familiar with. You have the same UI component, perhaps in two different contexts, and you want them to look a little bit different, but not too much. So in this scenario, we have our United States website on the left and our Chilean website on the right. So in the US, we're using the branding colors we're used to, but on the right, in Chile, we're partnered with a national bank there, and this means we need to use orange instead of blue. So in CSS, this can be pretty straightforward because it's just a button, right? It's a pretty flat DOM structure, let's say. But you can imagine that when it comes to more complex UI elements, you can get into specificity hell, and your CSS can quickly devolve into spaghetti. So what are we using to solve this issue? We're using a tool called Emotion, which is a CSS and JS library. If you're familiar with styled components, it's pretty similar to that. And I think recently there have been other CSS and JS libraries that have been deprecated in favor of Emotion as well. How this works, if you have never worked with styled components before, essentially you get to write your CSS in the JavaScript, which sounds scary, but it's actually awesome. And every single one of your components is going to receive a property called theme. This is provided by a component that lives at the root of the application, which is called a theme provider, and every single one of them can tap into this theme. And the theme, there's no magic there, really. It's just a plain JavaScript object. But because of the fact that it's JavaScript, you can also put other neat stuff in there, like functions. So for example, we're using our theme to also encode media query helpers. So it's really great. You give someone an entire toolkit for making things work with the theme. And as you can see here, the theme is super declarative to use. You just say theme.colors.mycolor. It can be, in this case, the primary color. So in the case of these two pieces of UI, you have absolutely no knowledge of what theme is being used on the component level. You don't have to make any modifiers for it, and you don't need to add a class to the body, for example. So this is really productive. It's pretty cool. It looks straightforward. But what about the fact that we're not only writing React apps? In fact, our tech stack, it's eclectic, we can put it that way. So our largest apps are written in React and Next, but we also have some other apps written in Elm, Jekyll, Riot, if you have even heard of that. And then we have some more traditional stuff like Ruby on Rails. And we have third-party tools, such as Salesforce Marketing Cloud. And okay, it seems pretty straightforward. When it comes to React, everything is going to work as expected. But what about all the rest? I mean, in some cases, it just doesn't make sense to migrate an old application that's working just fine in the field because you want it to have a few different colors, right? It's hard to make a business use case for that. And at the same time, with third-party applications, they're just never going to be written in JS. Can you imagine trying to convince Salesforce that their email template should be done in React? I mean, this doesn't work, right? So we need a solution that's going to be a little bit more platform agnostic. And you can imagine that if we were just using Sass, this would be kind of easy, right? You could just take all your SCSS files, you could concatenate them together, you could run them through the Sass processor, and then at the end you would end up with your nice files. But since our JavaScript is neatly tucked away into our components, it's a little bit trickier to get to. And on top of that, our computed CSS relies not only on the theme being provided to it, but also parameters or props that are passed to these components. So yeah, it's not as simple as the Sass solution. So to illustrate this kind of complexity, I made up this math equation, which basically says that however many themes we have, we need to multiply that by any possible combination of parameters that can cause our CSS to be computed. So how do we solve that? We do as we can with many problems in life. We write a node script that's going to do it for us. So how this works essentially is that you can take all of your UI components, you can render them headlessly inside of a node script, and every time you render a component, it's going to pipe its computed CSS into what's called the cache of emotion. So it keeps all of the CSS classes internally, and if you simply take all the themes and all of the properties that can be passed, this emotion cache will become full of all the CSS that you want, which sounds pretty cool, except for the fact that CSS in JS doesn't exactly have the most human-friendly or stable CSS class names. But luckily, there's a feature in Emotion that allows us to add a label to our CSS. And this means that we can actually annotate our components with BEM-style class names. What does this give us? It means that when you're working in React, you can use something that feels really native. And when you're working in plain CSS, you can get BEM styles. That's pretty cool, huh? Now, what does this give us at the end? It's the best of both worlds, right? You have modern CSS, and it's really easy to work with themes, but you don't leave out all the older or third-party applications that your design system really has to take care of. So with that in mind, as I said, we have more and more teams that are working in parallel. How are we going to make it so that it's really easy for people to contribute to our design system? I know there are a lot of companies that have a dedicated design system team, and that's something I would love to have one day, but it's just not a reality. We really need to make it user-friendly for people to add to our library, or else the couple of people who are maintaining it will just become a bottleneck for a bigger and bigger number of teams. So the first thing that we do is we try to automate as much documentation as possible. As I said, if a developer finds a component that's documented, there's a pretty good chance they're going to want to use it. So we're using this very early stage tool called Docs. So far, it has been a pretty good experience. And it's also leveraging a library that is called React DocGen. Maybe you are familiar with it. Essentially, this allows you to import a component. It's going to parse all of the comments that are written inside of your components file, and it's going to annotate your component and the prop types that are passed with the documentation that you provide. And this means that doing some kind of parsing of these components and their properties and displaying them in a nice documented table is extremely straightforward. I think it's like, 200 lines of code, and you have to do almost none of it yourself. So this makes it really easy that if people are looking at documentation, they have a way to know exactly how I use this component. Besides this, we're also using snapshot tests to ensure that we don't introduce certain kinds of CSS regressions. Now, I think snapshot testing has become pretty popular, but in case you're not familiar with how it's working, essentially you run the test one time. It records the assertion into a file, which is then committed to version control. And afterwards, you're able to assert against that information, which is stored into the file. So in this case, I'm writing a test that is saying when I make a tag that is selected, it should match the snapshot as it was previously written. Now, on its own, this is pretty useful for knowing when something changed, but Jest also has the option to add custom serializers into its workflow. So you can also get a serializer that's going to take the CSS styles from Emotion, and it's going to print them in a really nice way that you're able to view them and see exactly what changed. And since we are really relying on computed CSS to be the way we expect it to be, having this kind of security about what kind of side effects are being introduced when you change CSS in one place versus another is very comforting. All right, so let's recap. We started out by talking about a use case, right? This same UI component developed by two developers, created by two designers on parallel teams that ended up being exactly the same thing, and how we can avoid that. We talked about what a design system is, how you can combine ideas and the artifacts that you create into a system of UI that is able to evolve over time and is meant to handle change. We also talked about the specific challenges we had, how we had a growing team and we wanted to make them as efficient as possible without requiring them to know every in and out of the application they were coming into. We also talked about how we know that we're getting more and more products. And we also have a diverse tech stack, which we have had for a while. How are we going to handle that? Well, we use CSS and JS and a custom node script to get the CSS back out, so it's backwards compatible. And we also talked about, finally, the processes we use and how we make it easy for people to contribute. Now I'm going to show you what we built. So we spend so much time thinking about this design system, and there are so many choices that you have to make. But before I show you what we built, I want to show you where we came from. Now this is an act of vulnerability, because it's not pretty. So when you start out to create a design system, you do something that's called a design audit. And what this means is you open every single application that you intend to have covered by your design system, and you look at every single variant of the exact same thing, and you put it into this single place where you can analyze all the different use cases. So you see we have some real diversity and in this array of buttons. We have some bootstrap, we have some loading, notifications, outlines. I mean, there is so much going on here. And the amazing thing to me is that for most of these things, besides the bootstrap, of course, a developer and a designer spent a really long time thinking about how they could make it perfectly inconsistent with the rest of the buttons. And that is a huge waste. I mean, just thinking about how many hours it took to produce this slide of buttons, it's unbelievable. And it gets worse. This scales up to the application level. So thankfully, we're looking a bit better today, but before we started with our design system, we have samples from 3 different redesigns all live. So some apps just never made it through the redesign. Since I started at the company, we went through 3 different shades of blue as our primary color, and you can see they're all here. So what we really learned is that redesigning an application doesn't make sense. You have to do it in a systematic way. And that's why we introduced Circuit, which is the name of our design system. It has a few core properties such as typography, colors, spacing. We opted to use memory sizes for the names of our colors and spacings because we had struggled with extra, 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 extra large type. Maybe that sounds familiar to you. And now in our system, we have one button to rule them all. One which has been decided upon. Everyone knows this is the one button, and don't you dare introduce another button because it won't pass code review. The last thing I really want to show you is a real-life example of the design system in production. So you see this page. This is where one of our merchants can accept payments online. And what's below it is actually entirely coming from our design system. So there's almost no custom CSS required to implement this page. And I don't know about you, but the less CSS that I have to write, it is better. So this makes you really productive, right? You are focusing on business logic rather than browser compatibility. And for me, it just makes me feel so happy inside. Last thing, it's open source. So when we were creating our design system, we took a ton of inspiration from a lot of open source projects. And even though our project, I would say, is still under construction, as all design systems constantly are, you're completely welcome. Have a look and see how we solved some of these problems in real code. Thank you very much.